I am Dr. Gaurav Saxena, Associate Professor in EC Department. Today I have discussed the emerging domain in electronics and engineering. This is the BEC 201. Uh, this is a first year subject, and which is associated in the second semester students. And this is the topics. Whole of the topics I already discussed. So today I have discussed the unit 3. So unit 3 is what is the operation amplifier and what is the introduction of operation amplifier, what is the practical op-amp circuit, just like a inverting amplifier, non-inverting amplifier, unity follower, summing amplifier, integrator and differentiator. So this is a very important topics which has been asked in the AKTU examination. So Robert L. Bolester, this is the textbook and the reference books we have to be introduced. This is electronic devices and circuits, which is Pearson education system. So the topic is op-amp and its applications. So what is the meaning of op-amp? What is operational amplifier? The full form is op-amp is operational amplifier. So what is the symbol of op-amp? So this is the symbol of op-amp. So I discuss here. This is the non-inverting terminal. This is the pin number 3 in IC 741, or we have to see that the IC is associated for op-amp is IC 741. This is the non-inverting terminal and this is the inverting terminal. So pin number 2 is associated with the inverting terminal. And this is the biasing. So plus VCC is to be associated with the pin number 7, and pin number 4 is introduced to the minus VCC. So this is the biasing voltage we have to be given in the IC 741. So the output we have to be taken at pin number 6. So this is the IC diagram or internal diagram of the operational amplifier. So this is the what is the meaning of the non-inverting terminal. So non-inverting terminal, that terminal if we applied any input. So suppose we have to be applied a sinusoidal input. So they amplify the signal, and this is a non-inverting, that means the amplitude is to be same phase at the input. So that means the output waveform to be amplified and the same phase. So we can say this is a non-inverting terminal. But in the case of if we apply a signal, input signal in an inverting terminal, so the output is to be meet, which is amplify having a 180-degree phase shift. So we can say this is a inverting terminal. So the what is the internal diagram of this 741 IC? So internal diagram. So what is the internal diagram? This is minus, this is plus, this is the inverting input, this is the non-inverting input, this is the input resistance, this is Ri or Zi, this is the input resistance of that particular op-amp, and this is a voltage source, this is the output impedance, and this is the output terminal. Output terminal is to be just like a plus minus. So this is voltage source. So voltage source, what is the voltage source? This is defined by AD into VI. So AD is the gain of that particular operational amplifier. So this is the small signal model or internal diagram of the 741 IC or IC 741 internal diagram. So this is the input impedance, or we have to see that Zi, and this is the output impedance. And so what is the meaning of operation amplifier? If we applied both the inputs, we have to be applied at the inverting and non-inverting. So they amplify the difference signal. So what is the difference signal? So if I can say this is V1 signal, this is V2 signal. So what is the difference signal? Difference signal is VI V1 difference V2. So if the amplification factor of this IC741 is AV, so what is the output? Output is the gain into input signal. Yeah, input, that means the difference signal. So the what AV into VD. VD, what is the VID? That means in V1 minus V2. So this is the basic operation of operational amplifier. So second terminology is what is the ideal op-amp. So why we can say this is ideal op-amp and what is the specification of ideal op-amp. So ideal op-amp of that op-amp. So these specification are given below. First one is the input impedance. The input impedance of ideal op-amp should be infinite. So that means the input impedance of any ideal op-amp should be the infinity ohm. That means the impedance, if we have to be taken in the ohms, so that the input impedance of ideal op-amp should be infinity. That what is ZO? ZO is the output impedance. So output impedance of ideal op-amp should be 0 ohm. Third one is what is the open loop gain, AOL. What is the meaning of open loop gain? So if any op-amp, if we not applied a feedback, positive or negative, so such op-amp is called the open loop feedback, open loop operational amplifier. So the open loop gain of any ideal op-amp should be infinite. And the bandwidth, fourth one is what is the bandwidth? Bandwidth is infinite hertz. So all the signal, what is the meaning of the bandwidth infinity? So in a practical purpose, the op-amp having the bandwidth is 1 megahertz to 2 megahertz. But in the ideal case, whatever signal you have to be given that particular op-amp, they can amplify. So the bandwidth of such ideal op-amp should be the infinity. So we can say the bandwidth of ideal op-amp should be the infinite. Fifth one is CMRR. What is the meaning of CMRR? CMRR stands for the common mode rejection ratio. So what is the meaning of CMRR? CMRR stands for the rejection capability of the op-amp should be measured in the terms of CMRR. So CMRR is the ratio of difference mode gain upon common mode gain. So if we apply a different input at the input signal, terminal, so the gain they have to be produced. That means the V1 difference V2 and V0 is the output. So the difference mode gain is V0 upon V1 minus V2. So that gain is AD. And the common mode gain, what is the meaning of common mode gain? So I just explain. This is the minus, this is plus, this is the inverting input, this is the non-inverting input. So if we apply it, this signal is to be 5 volt and this is to be grounded. So the what is the difference? What is the output? So output should be infinite because this op-amp should be ideal one, having a open loop gain is infinity. So what is the difference input? 5 minus 0. So that means what is the output upon input ratio? So output is infinity and the input is 5 volts. So what is the gain? Gain should be infinite. So that means this is the difference mode gain. So if we apply a different input at the input terminal, so then we achieve a such output. So what is the output upon the input ratio, voltage ratio? That is called the difference mode gain. And if we apply a same input at the input terminal 5 volt, so if the output should be the 0, so the gain is a common mode gain. So such gain is called the common mode gain. So the CMRR for ideal op-amp should be infinity. That means that the rejection capability is to be judged by the any op-amp by the CMRR, and the unit of this one is dB. So how we change if the CMRR is given in the linear form, so we easily change in the dB form. by using the formula 20 log base 10 AD by AC, where AD by AC is to be given in the linear form. And the other one is slew rate. What is the slew rate? So the what is the meaning of slew rate? Maximum output change with respect to the time, where time is taken in the microsecond. Such rate is called the slew rate. That means the dV naught upon dt max, where the unit is volt per microsecond. That means this one is infinite volt per microsecond for ideal op-amp. So if we choose a ideal op-amp, or if we choose a practical op-amp, so the slew rate should be high. That means the that particular op-amp is the less sluggish with respect to the others. And the other one is PSRR, power supply rejection ratio. So it should be 0, and so that means the rejection in the power supply, if we apply a 5 volt signal, so they give in a 4.9999 volt. So the difference between the switching voltage is to be very normalized range. That means the 1 to millivolt, 1 millivolt to the microvolt. So but in the case of the ideal op-amp, the PSRR, power supply rejection ratio, should be 0. And this is the ideal op-amp characteristic. And the practical op-amp characteristic, what is the meaning of practical value or nominal practical value for IC741 micro A, which is given by the Fairchild. So Zi, what is the Zi for practical value? Which one is 1 to 2 mega ohm? And what is the value of output impedance? Output impedance in the range of 75 ohm. What is the open loop gain? Open loop gain is very high, in the range of 10 to the power 5. And what is the bandwidth? Bandwidth is to be taken at the 1 megahertz. And what is the CMRR? CMRR is the range of 60 to 90 dB, which is very good for any op-amp. The slew rate is 0.5 volt per microsecond, and the PSRR, which should be 1 microvolt. So this is the ideal characteristics of any op-amp, and this is the Fairchild, and any practical characteristics of any op-amp we have to be discussed here. Next is, what is the application of op-amp? Very, very important. What is the application of operational amplifier? The first application of op-amp is inverting and non-inverting amplifier. Inverting and non-inverting amplifier. So this is very, very important topic. What is the meaning of inverting amplifier? If we want a output should be 180-degree out of phase, and also we want a amplification of that particular input, so we use a inverting amplifier. So what is the diagram and what is the derivation of this? We have to be see here. This is minus, this is plus, this is the inverting terminal, this is a non-inverting terminal. This is input resistance, or we have to be see that Ri. This is the feedback resistance. We have to be given a negative feedback, because negative feedback given a stable output. If we give in a positive feedback, so this op-amp works as an oscillator. So if we use a inverting amplifier, so we apply a input at the inverting terminal. So we can say this is a inverting amplifier, and the plus terminal is to be grounded. So that means this is the circuit diagram of IC7. This is the circuit diagram of inverting amplifier by using the IC741. And this is the supply voltage, plus 15 volt and minus 15 volt. This is the output. So first is, what is the output voltage in terms of the VI, RI and RF. So RF is the feedback resistance, RI is the input resistance, VI is the input voltage. So we want a establish the relation between the output to the input voltage in terms of the RI and RF. So this is the, suppose this is a terminal 1 or node 1, this is a node 2. So we have to be just see that here the one more ideal op-amp characteristic is bias current. So bias current should be 0 amp. So what is the bias current? So if the mismatching in the ground terminal, if I can say this is ground, or we can say this is 0 volt, but this is not a perfectly 0 volt, or they have to be given a some potential 0.0001. So the different signals to be different. So we apply a another voltage source to nullify that particular current, and we have to be which is opposed to the that particular current. So such current is called the biasing current. So ideally the bias current should be 0 in the bias current should be 0 in the positive terminal or in non-inverting and inverting terminal. Okay, so first assumption is op-amp should be ideal one. The op-amp should be ideal one. The first assumption to establish a relation in non-inverting amplifier by using op-amp. So first assumption is op-amp should be ideal one. Second one is the bias current should be 0, because the op-amp should be ideal. So that means the bias current should be 0 ampere, which is equal to the I bias minus. Third one is virtual ground. So what is the meaning of virtual ground? If this terminal or node 1 and node 2 having a same voltage, because the inlet current I bias should be 0, that means that this voltage is to be appear at the node 1. So that means the by using the virtual ground condition, what is the virtual ground? This terminal is not connected directly to the ground, but the current which is entering the IC741 should be 0, which are same here. So that means that this potential 2 at node number 2 is equal to the node number 2. By using the virtual ground condition, voltage at node 1, which is equal to the voltage at node 2, which is equal to 0 volt. So three assumptions we have to be taken for apply a relation between the output and input voltages for op-amp works as an inverting amplifier. So this voltage should be 0 appear here. So fourth one is apply KCL at node 2. Apply KCL at node 1, sorry. Apply KCL at node 1. So suppose the I1 current flow in that particular terminal and the I2 is to be connected to flow that particular terminal. So the I bias minus is equal to 0, and this voltage to be, this is 0 volt, and this voltage to be appear at 0 volt here. That node 2 is equal to voltage is equal to the node 1 voltage by using the virtual ground condition. So if we apply a KCL at node 1, so that means the I1 is equal to the I bias minus plus I2. So that means the I bias should be 0 for ideal op-amp. So that means the I1 is equal to I2. So I1, what is the I1 current? I1, we know that according to the Ohm's law, current is equal to the potential difference upon resistance. So what is the potential difference? We know that current flow always at the higher potential to the lower potential. So that means the I1, what is the I1? Vi minus 0 volt upon Ri. So that means the Vi minus 0 upon Ri, which is equal to the, this is the I1 current. What is the I2 current? So I2 current is the, this is 0 volt, this is V0 volt. So what is the potential difference? Potential difference, because the current direction is to be, we have to be assumed that this is one is clockwise. So that means the potential difference is 0 minus V0 upon Rf. So we easily calculate the what is the V0. V naught is equal to the minus RF upon RI into Vi. So this is the relation between the output and input voltages for inverting amplifiers. So some question is to be asked, you design a op amp as a inverting amplifier having a gain is 10. Having a gain is 10. Gain 10 के लिए you have to just design a inverting amplifier by using op amp. So we put the value of this is 10 kilo ohm and Ri is 1 kilo ohm. So what is the gain? So gain in the inverting amplifier is depending upon the what is the feedback resistance upon input resistance. If Rf is 10 kilo ohm and the Ri is 1 kilo ohm, so the gain in non-inverting amplifier, which one is equal to the 10. So the output should be the V naught is equal to minus 10 of Vi. So by using the suitable feedback resistance and the input resistance, we easily design a inverting amplifier for having all arbitrary gain. Second one is non-inverting amplifier. Non-inverting amplifier. The second application of op amp is non-inverting amplifier. So what is non-inverting amplifier? So I just design a op amp which is work as a non-inverting amplifier. So this is the input resistance Ri. This is the feedback resistance Rf. This is the output voltage V naught. This is IC 741, which belongs to the op amp IC, and this terminal is to be connected at the ground terminal and this connected at the input terminal. Because we design a non-inverting amplifier, so we apply a input in the non-inverting terminal. So if we apply a input voltage in the inverting terminal, so you see that if we apply a voltage in the inverting terminal, so we can say this is a inverting amplifier. If we apply a input voltage in the non-inverting terminal, so we can say this is a non-inverting amplifier. So the three assumptions are same. Op amp should be ideal one, bias current should be 0, and by using the virtual ground condition, voltage at node 2 is equal to the voltage at node 1, which one is equal to Vi. Same process here. We apply a KCL at node 1. Suppose this one is I1, this is I2, and the bias current should be 0. So that means I1 is equal to the I2. We apply a KCL at node 1. That means entering current, which is outlet current, which is equal. That means I1 at node 1 is the inlet current, I2 is the outlet current, which is equal to I2. So I1 is equal to I2. How we calculate the I1? I1 is the potential difference upon resistance. So what is the potential difference? Potential difference is, we have to be assumed that the current direction is there. So this is the higher potential, this is the lower potential. That means this is ground. So this potential is 0 volt. So that means 0 volt minus Vi upon what is the resistance? Ri. So this is 0 volt minus Vi upon Ri, which is what is the output voltage? Output current is I2. So I2 is the potential difference. What is the potential difference? Vi minus V naught. So Vi minus V naught upon Rf. So how we calculate it? 0 minus, yani ki that means the Vi upon Ri, which is equal to Vi upon Rf minus V naught upon Rf. So you have to take in here V naught is one side and Vi is one side. V naught upon Rf, which one is equal to Vi. You have to take in a common 1 upon Rf plus 1 upon Ri. So we take in a Rf into Ri is the LCM. So Rf, this is Ri, this is Rf into Vi. Which one is equal to V naught upon Rf. So Rf से Rf is to be cancelled out. That means V naught is equal to the So if we divided this by Ri, so that means the Vi Ri upon Ri should be 1 plus Rf upon Ri. So this is the output voltage in terms of the RF, Ri and the input voltage. So this is a very important relation for finding the op-amp works as a non-inverting amplifier. So such small example I have to be taken. Some design example I have to be taken here. I have to be introduced. If design a non-inverting amplifier having gain is 5. So we know that the gain factor in non-inverting amplifier is 1 plus Rf upon Ri. But in the case of the inverting amplifier, the gain factor is Rf upon Ri. But in this case, we have to be design a non-inverting amplifier having gain is 5. So what is the gain in non-inverting amplifier? Which one is 1 plus Rf upon Ri? Which one is equal to the 5? So that means Rf upon Ri is equal to 4. So that means the feedback resistance, which one is equal to the 4 Ri. So that means if we design a non-inverting amplifier having a gain is 5, so if we introduce a Rf is equal to 4 kilo ohm, suppose we have to be design a non-inverting amplifier having a gain is 5. So if we assume the feedback resistance is 4 kilo ohm, so Ri should be 1 kilo ohm. If we put it in this parent equation, so V0 is equal to Vi 1 plus Rf. What is the value of Rf? 4 kilo ohm and the Ri is 1 kilo ohm. So that means the V0 is equal to 4 plus 1 is equal to 5 Vi. So we easily design a non-inverting amplifier by using the op-amp. The third application of op-amp is unity follower. So what is the meaning of the unity follower by using op-amp? In the next lecture, we have to discuss about the another application of op-amp. Just like a unity follower, op-amp works as an integrator, differentiator and difference amplifier. Thank you.